Lesson 11-2 is special right triangles. So we're going to go over 30, 60, 90 triangles and 45, 45, 90 triangles. You guys did cover these in geometry, so hopefully a lot of this is going to be review. All right, so 30, 60, 90 triangles. A 30, 60, 90 triangle is half of an equilateral triangle. So if we think of an equilateral triangle, all angles in an equilateral triangle are 60 degrees. So that would make this angle right here 60, because this whole angle is 60 and so is this one, because that adds up to 180 degrees. Well, we cut this in half, we have 90. And then if we bisect this 60-degree angle up here, we cut it in half, this is our 30-degree angle. So we have our 30, 60, 90-degree triangle. So let's say we call this side up here 2. That would make every side 2. But if we bisect this side, that makes this side 1. And up here, we're going to call this square root of 3. So have this down in your notes. This is our standard 30, 60, 90 triangle, and what we're going to use moving forward. So 90 degrees, 30 degrees, 60 degrees. Across, opposite of 30 is 1, opposite of 60 is square root of 3, and our hypotenuse is 2. This is going to be our reference triangle for 30, 60, 90. So how do we use this? Well, find the sine of 30 degrees. Well, let's draw our 30, 60, 90 degree triangle. So if I draw this out, I have 30, I have 60, across from 30 is 1, across from 60 is root 3, and our hypotenuse is 2. So I want the sine of 30. Well, I know sine from SOHCAHTOA is opposite over hypotenuse. So if I'm looking at 30 degrees, I'm looking at this angle here. Opposite is 1, hypotenuse is 2. So the sine of 30 degrees equals 1 over 2, 1/2. So sine of 30 is 1/2. We can do this for many other, we could do cosine of 60, we could do tangent of 30, we could do lots of other ones. So let's see, if we want to do, let's say, tangent of 30. So let's write this one down. So we have tangent of 30 degrees. So we're going to use that same angle. So we're using the same angle up here. Now, tangent is opposite over adjacent. So opposite is 1, adjacent is square root of 3. Now 1 over square root of 3. But we need to be very careful here. So that's why I picked this one specifically, because in the denominator we cannot have a square root, just like we can't have an imaginary number. So if we want to get rid of a square root in the denominator, we need to rationalize our denominator by multiplying by the square root of 3 in the denominator and in the numerator. So when I multiply this, the tangent of 30 becomes 1 times square root of 3, which is square root of 3. And square root of 3 times square root of 3 is just 3. So the tangent of 30 becomes square root of 3 over 3. All right, we've got 2 more examples here. Find each trig ratio. We've got the tangent of 30, which we just did. So let's change that up. We'll do the tangent of 60 degrees and cosecant of 60 degrees. So pause the video, draw your reference triangle, and go ahead and try and figure out tangent of 60 and cosecant of 60. All right, now that you've tried these on your own, so the tangent of 60 degrees, if I'm looking at 60 here on my reference triangle, and I know that tangent is opposite over adjacent, I have the square root of 3 over 1, which is just the square root of 3. So the tangent of 60 degrees equals square root of 3. Cosecant of 60. So cosecant goes with sine. It's the opposite of sine. So if sine is opposite over hypotenuse, cosecant is going to be hypotenuse over opposite. So I'm still looking at 60 degrees here. So 60 degrees, I have hypotenuse over opposite, square root of 3. But we know that it is a big no in math to have a square root in the denominator. So we are going to multiply to rationalize the denominator. And if I rationalize the denominator, I get the cosecant of 60 degrees equals 2 times root 3 over 3. So that would be the cosecant of 60 degrees. Now let's look at 45, 45, 90 triangles. A 45, 45, 90 triangle is half of a square. So if we're looking at our picture here, we've got obviously all angles in a square are right angles. And if our diagonal bisects our angle, it cuts a 90-degree angle in half, it's half of 90. So that makes both of these 45. Well, if we have a square, all sides are the same. So if we call this side 1 and this side 1, well, what is our hypotenuse? Well, Pythagorean theorem, 1 squared plus 1 squared equals c squared. So 1 squared plus 1 squared equals c squared. So 1 plus 1 equals c squared. 2 equals c squared. Take the square root, giving us our diagonal here is square root of 2. So here is our reference triangle for 45, 45, 90. Make sure we have this down in our notes. We have 45, 45. Both sides are 1 with our hypotenuse being square root of 2. This is what we're going to use moving forward. So an example, find the cosine of 45 degrees. So draw my triangle. Whoops. Draw my triangle. I've got 45 and 45. So essentially I could use either angle. I have 1, 1, root 2. So they're both 45 degrees, so it doesn't matter which angle I look at. I'm looking, let's choose this angle here. So if I'm looking here, I have opposite, adjacent, hypotenuse. Cosine is opposite over hypotenuse. So the cosine of 45 degrees is going to be adjacent, 1, over hypotenuse, root 2. But can't have that square root in the denominator, so I have to rationalize my denominator. Multiply by root 2 in the numerator and the denominator, giving us the cosine of 45 degrees to be square root of 2 over 2. Last set of examples, we have the tangent of 45 and the secant of 45 degrees. So go ahead and try these two on your own while you pause the video and then play to check your work. All right, so if I'm using my triangle here, the tangent of 45, I know tangent is opposite over adjacent. So the tangent of 45, I could choose either 45-degree angle. If I choose this one, this is opposite, adjacent, hypotenuse. I have opposite over adjacent, giving me 1 over 1, which just simplifies down to 1. So the tangent of 45 is 1. So secant. Secant I know goes with cosine. So cosine is adjacent over hypotenuse. So this is the reciprocal, hypotenuse over adjacent. So secant of 45 degrees is square root of 2 over 1. So the secant of 45 is square root of 2. Now, make sure that we know these 30, 60, 90, and 45, 45, 90 triangles. Right now, we're looking at these very basics of 45, 30, and 60-degree angles, but we're going to take this and apply it to a bunch of different angles in different quadrants, like looking at the tangent of 150. So these reference triangles are going to come in handy, so make sure we have these memorized.